Imagine floating alone in the darkest night you've ever experienced. But this isn't just any darkness. It's the absolute void of space where even sound itself cannot exist. No up, no down, no air to breathe, and the nearest human being is hundreds of miles away on Earth below. This isn't science fiction, it's the reality faced by every astronaut who ventures into what might be the most hostile environment humans have ever encountered. But what's truly terrifying isn't what's there, it's what isn't. Space isn't just empty, it's an emptiness so profound that it defies our earthbound understanding. When a human body is exposed to this void, something horrifying happens within seconds. Your blood literally begins to boil at body temperature because there's no atmospheric pressure to keep it liquid. The moisture on your tongue and in your eyes starts to bubble and evaporate. You have about 15 seconds of consciousness before the oxygen deprivation takes hold. This isn't speculation, these are the cold hard physics of exposure to space's vacuum. In this vast emptiness, what we think of as empty space isn't truly empty at all. At the quantum level, it's a seething foam of virtual particles popping in and out of existence, creating and annihilating themselves in time spans too short for us to detect. But this quantum vacuum holds an unsettling secret. It contains enough energy in a single cubic centimeter to boil all Earth's oceans. The only reason it doesn't is because this enormous energy exists in perfect balance for now. The void's hostility extends far beyond its emptiness. Space is a realm of temperature extremes that would shatter our understanding of hot and cold. In direct sunlight, an astronaut's suit can reach 250 degrees Fahrenheit while the shadowed side plunges to minus 250 degrees. This isn't gradual, the transition happens instantly because there's no air to conduct heat or ease the thermal shock. The same lack of atmosphere that would boil your blood also means you can freeze and burn simultaneously. The radiation in space adds another layer of horror. Without Earth's protective magnetic field and atmosphere, you're exposed to cosmic rays, high-energy particles traveling at near light speed that can pass straight through your body, damaging DNA and increasing cancer risk. Solar flares can deliver lethal doses of radiation in hours. This invisible threat is constant and unavoidable in the void. But these immediate threats pale in comparison to the true horror of space, its incomprehensible vastness. The distances are so enormous that our brains, evolved to comprehend distances between trees and tribal hunting grounds, simply cannot grasp them. Light, the fastest thing in the universe, takes 8 minutes to reach us from the sun, 4 years to reach the nearest star, and 100,000 years just to cross our own galaxy. The void between galaxies is so vast that light takes millions of years to cross it. In this void lurk phenomena that make these distances even more terrifying. Rogue black holes ejected from their home galaxies wander the space between stars. These invisible monsters, detected only by their gravitational effects, could be anywhere. Some scientists estimate there could be millions of them in our galaxy alone. Their presence unknown until they're close enough to begin pulling on nearby stars. The cosmos holds even greater horrors. Gamma-ray bursts, the most powerful explosions known in the universe, can sterilize entire galaxies with radiation. These cosmic death beams, likely caused by colliding neutron stars or massive stellar explosions, release more energy in seconds than our sun will emit in its entire lifetime. If one occurred within a few thousand light-years of Earth, it could strip away our ozone layer, exposing all life to lethal solar radiation. Then there's dark matter. Invisible, mysterious matter that makes up 85% of the universe's mass. We can't see it, touch it, or interact with it in any way except through gravity. It passes through our bodies constantly, ghost-like, yet its gravitational effects shape entire galaxies. This invisible scaffold of the cosmos reminds us that we understand only a tiny fraction of what exists in the void. But perhaps the most terrifying possibility is vacuum decay. According to quantum field theory, our universe might exist in a false vacuum state, essentially a cosmic metaphase that could collapse at any moment. If this happened, a bubble of true vacuum would expand at the speed of light, obliterating everything in its path by rewriting the fundamental laws of physics. We wouldn't see it coming. No warning, no escape, just instantaneous obliteration spreading across the cosmos. The psychological impact of confronting this void has been documented in real astronaut experiences. In space, the human mind faces a unique form of isolation. The overview effect, the profound shift in awareness reported by astronauts when viewing Earth from space, can be both enlightening and terrifying. You're confronted with the reality that everything humanity has ever known exists on a tiny blue marble, suspended in infinite darkness. Time itself behaves strangely in space. Without the regular cycle of day and night, astronauts' circadian rhythms become disrupted. The International Space Station orbits Earth every 90 minutes, experiencing 16 sunrises and sunsets daily. This constant shift between light and dark, combined with the absolute silence of space inside their helmets, creates a surreal environment that challenges human psychology in unique ways for astronauts. The dangers we've discussed are just what we know about. The void likely holds threats we haven't yet discovered or can't even comprehend. Consider this. Every time we develop more powerful telescopes or more sensitive instruments, we find new phenomena that challenge our understanding of physics. When we detected gravitational waves for the first time in 2015, it opened up an entirely new way of observing the universe and revealed colliding black holes we never knew existed. The challenges of surviving in this void become even more apparent when we consider long-term space travel. The human body, evolved for life on Earth, begins to break down in space. Muscles atrophy, bones lose density, and the eyes change shape due to fluid shifts in microgravity. Extended exposure to cosmic radiation can damage the brain, potentially affecting both cognition and emotional regulation. These aren't just theoretical concerns, they're documented changes in astronauts who've spent extended periods in space. Our best technology seems almost primitive against the void's challenges. Even our fastest spacecraft would take tens of thousands of years to reach the nearest star. The void's emptiness makes carrying enough fuel nearly impossible. Every gram of fuel requires more fuel to move it. The nearest potentially habitable exoplanet is 4 light-years away, yet we have no technology capable of reaching even a fraction of light speed. The philosophical implications are equally daunting. Our species evolved on a warm, wet planet, protected by a magnetic field and atmosphere, orbiting an unusually stable star. We exist in a tiny bubble of habitability in an overwhelmingly hostile universe. The void reminds us that we are not just alone, we are impossibly, incomprehensibly alone. The nearest intelligent civilization, if one exists, could be so far away that their light hasn't had time to reach us in the entire history of our species. Yet perhaps the most unsettling aspect of the void is what it reveals about our own existence. Every atom heavier than hydrogen and helium in your body was forged in the heart of a dying star. We are, quite literally, made of stardust, formed from matter that drifted through the void for billions of years before becoming part of us. The void isn't just out there, it's part of our origin story. This brings us to a profound question. As we stare into the void, are we looking at our future? Humanity dreams of becoming a spacefaring civilization, but the cosmos seems designed to prevent just that. The distances are too vast, the dangers too numerous, and the void too hostile to our fragile biology. Yet here we are, a species born from the void itself, contemplating our return to it. So I leave you with this thought: when you look up at the night sky, you're not just seeing distant stars, you're looking into an abyss that holds both our origins and possibly our destiny. The void of space isn't just scary because it's empty, it's scary because it forces us to confront our own cosmic insignificance while simultaneously challenging us to transcend it. What do you think? Are we destined to remain bound to our planetary cradle, or will human ingenuity find a way to overcome the void's countless challenges? Share your thoughts in the comments below. How would you face the psychological challenge of being alone in space, knowing that the slightest mechanical failure could expose you to its endless emptiness? Join me next time for more explorations of the cosmos's greatest mysteries. Because in the end, understanding the void isn't just about science. It's about understanding our place in a universe that seems designed to make our existence as improbable as possible.